welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so you should check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode to get a $20 credit and launch a new server in under a minute. And for complete visibility into the health of your pipeline, including deployment tracking and powerful alerting driven by machine learning, Datadog has got you covered. With their monitoring, metrics, and log collection agent, including extensive integrations and distributed tracing, you'll have everything you need to find and fix performance bottlenecks in no time. Go to dataengineeringpodcast.com/Datadog today to start your free 14-day trial and get a sweet new t-shirt. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. Your host is Tobias Macy, and today I'm interviewing Yair Weinberger about Alooma, a company providing data pipelines as a service. So Yair, could you start by introducing yourself?
Yeah, thank you, Tobias. I'm Yair, one of Alooma's founders and CTO. I spent my time building data pipelines in different places. I spent about 12 years in the military in Israel, and about 4 years in advertising technology, a company called Convert Media that was eventually acquired by Taboola. And throughout that time, I was focused on building data pipeline over and over again in different places. And that's what brought me to start Alooma as well about 4.5 years ago.
And do you remember how you first got involved in the area of data management?
There was just a lot of data to process, and someone had to do it at that time. The name data engineer was not in use yet. It was about 15 years ago. We started by trying to create a way to ingest data that was generated back then in the military into somewhere where analysts can access it. And that proved to be not such a trivial problem. And that pretty much was the same course for the last 15 years.
And so, as we mentioned, we're talking about your company, Alooma. So I'm wondering if you can describe a bit about what Alooma is and does and the origin story that brought it about.
Yeah, sure. So when about 4.5 years ago, me and my other two founders, Yoni and Rami, we thought there is a problem in the data integration space. I mean, we felt that we are building the same product or the same thing over and over again, wherever we are at, in order to ingest data and to, make data ready for analytics, process data. And when we started Alooma, actually, we what we thought is this is not a new problem. That problem exists for like 30 years. So why is it so difficult? There are big companies out there. Almost every big company like Oracle, Microsoft, IBM, Cisco has some product around Dell, has some product around data integration. So why are we finding ourselves building the same thing over and over again? And we actually when we started the company, we actually thought we are missing something. I mean, our initial reaction was we must be missing something. There is something that we are unaware of. I mean, how come this doesn't work for such an old problem and so much money invested in trying to solve that problem? So what we did is we went ahead and tried to talk to as many companies as we could. So as an engineer, my tendency, and all of us are engineers, so our tendency was to get in a room and start coding. But we thought that if we do that and we are indeed missing something, then we might never find out what we're missing. So we went out of our comfort zone and went to talk to about 150 different companies, most of them in the Bay Area, but all over the place as well, and try to ask them, how do you ingest data today? What works? What doesn't work? And then we heard a very similar story over and over again from those 150 companies, and they were all shapes and sizes. We got to someone at Home Depot and Coca-Cola, and then we got to someone at 5 people startup in like a basement. So we pretty much heard the same story over and over again. And that story was in the data integration space. There were traditionally two different product categories. One category was the ESB, or Enterprise Service Bus, with companies like TIBCO and a newer company, MuleSoft, recently acquired by Salesforce, and which were focused around communication between different applications inside the org. And it was focused around on-premise applications and real time. So that, let's say the org has, an enterprise has 1,000 internal applications. You only need to connect each and every one of them to the bus instead of creating like n squared connection connecting each and every one to each other. And the other type was ETL, or extract, transform, and load, where traditionally, again, companies like Informatica, Microsoft, SSIS, Oracle Data Integration, traditionally focused around batch loading of data and preparing it for analytics. So extracting the data from wherever it resides, some transformation to make the data ready, and then loading it into the favorite like analytics or BI tool. And again, traditionally this was done in what is referred to as OLAP cubes. So some BI software that holds a cube inside it that's already usually has all of the data in memory. And then that worked for many, many, many years. But what we found out in those conversations is that two major changes have happened, and that resonated with our experience, with our difficulties to use the incumbent products for data integration. So one thing, and you know what, maybe in retrospect that sounds very trivial. Hindsight is always 2020, but at the time we took some time to get to those conclusions. So the first was that everyone is moving to the cloud. And the cloud, actually it means, in that context of data integration, it means two things. One is that the data itself is moving into the cloud, is moving into, cloud storage like Amazon S3 or Google Cloud Storage or Azure Blob Storage. And then also that, or of course, cloud data warehouses like Amazon Redshift or Snowflake or BigQuery, etc. But it also means that some of the applications are moving to the cloud as well. So companies started using SaaS instead of using on-premise applications. So Salesforce replaced Siebel, and we have Marketo and HubSpot and Zendesk, and pretty much every company today is using a lot of different SaaS vendors. So even the applications themselves are no longer on-prem, no longer part of the org. And on the other hand, what we've seen is that real-time data is becoming more and more important for more business use cases. And I'm sure everyone who listens that took an Uber in their life, and Uber has this amazing feature of surge pricing, where the price is being determined on the fly according to supply and demand. And I'm now in Israel, in Tel Aviv, and we don't have Uber here because of government regulation. And on the rush hour, it's just impossible to get a taxi. But in order to make that possible, to get the price dynamically allocated using supply and demand, you need real-time data. You need real-time access to the passengers, to the car's data, etc. And you cannot, and the traditional ETL tools, they work in batches. They work every day, maybe every 12 hours. And then what we've heard over and over again is whenever we are using something in the cloud or we need real-time data, we are building it ourselves in-house using open source tools. So we spin up Kafka and Spark or Storm or, all of those Apache open source great projects that allow us to build a real-time data pipeline in the cloud. And that was the trigger for us to start Alooma. Because what we thought to ourselves is, if so many companies are building this in-house and are taking, putting a team of engineers, and there is even a new title, data engineer, that didn't exist 10 years ago, and telling them, build that pipeline for me, maybe there is a good spot in the market to build a product that can do that as well.
You mentioned that there was this need for access to real-time data, and with the advent of the cloud and SaaS, it was no longer as simple as just plug everything into the enterprise service bus or just rely on this batch ETL architecture. And so I'm wondering if you can dig a bit into how Alooma is architected and what your decision-making process was around whether to go with the stream versus batch architecture for it.
Yeah, sure. So the main, and again, following that footstep, we had two main, following those assumptions that we found out, we had two main core decisions when we started architecting Alooma, which one was to make everything in the cloud. We are going to host Alooma 100% in the cloud. It is going to be a multi-tenant platform, and we are going to talk about the challenges of that later. But 100% multi-tenant, running exclusively in the cloud, and with great focus around cloud integration and cloud data warehouse. And the other was to build Alooma around streaming data. So we want to try and turn everything in the world into streaming. And not always it is possible. Sometimes there is just data that you cannot get streaming, especially if you're getting it from an external third-party source. But a lot of data sources that traditionally are not streaming, we have worked very hard to turn them into streaming, into let's say, an immutable set of changes. And actually, I highly recommend a blog post by Jay Krebs, which is called the Log, which explains how everything is an event stream. If we look at a database, we need to look at the transaction log of that database as an event stream. If we look at the changes that happen over time to, let's say, something that's being updated, we need to look at every update as an event instead of just looking at the final value at each point. So that's also a core thought around the Alooma architecture. Try and make everything into an event stream. Now, traditionally, I think we can divide the different types of data that people want to ingest into 4 categories. One is files. They have, you have files, and those files can come from many, many different places or sources, and you want to ingest those files. And ideally, what we try to do there, again, even that we try to make as streaming as possible by, for example, agents that sit on the log directory and just ship every new log row as it's being written, or just even if it's polling some location as frequently as possible and streaming the file in a micro batch, that's still as fast as possible. Then there are clickstream events where they are by nature streaming. Let's say if we have some JavaScript or SDK for iOS or Android that are sending events, those are just streaming by nature. The third category, which was maybe the most difficult to turn into streaming, was RDBMS. So you want to ingest data from, let's say, a transactional database and use and run some analytics on top of that. That's a very common use case. And as I mentioned, what we try to do is read that transaction log. Sometimes it's easier to access transaction log. Sometimes it's very, very difficult. And the fourth and last is APIs. So if we need to access some kind of an external SaaS API, unfortunately, that's not, in those cases, streaming is not always possible. So again, you need to look into the API and you need to see how can I implement change data capture? How can I capture all the changes from that API and do your best? And again, some APIs, it's possible. With others, it could be very difficult and you have to work with micro batches. But the core idea was to make everything streaming or data streams and then build the capabilities of stream processing inside the product itself. Make sense so far?
Yes, absolutely.
Great. So then we turned everything into streaming and we tried to distill, okay, what are people doing when they're building a data pipeline? So we know they spin up Kafka. We know they might spin up Spark streaming or Kafka streams today or Storm, but what are the core components of a pipeline if you try to dissect it? And we broke it down into a couple or a few main components and then try to tackle each and every one of them. So as I mentioned, one part is just ingesting the data. Getting data into the message bus or to Kafka. By the way, Alooma also uses Kafka under the hood. It's an amazing product, but we've seen a lot of companies using like a cloud vendor solution like Google PubSub or Amazon Kinesis. But just getting everything into the message bus, that's the integration or ingestion part. And that's even table stakes. I mean, you cannot build a data pipeline if you cannot ingest the data. From there is one component of running code on the data. So you have data, you need to process it somehow. You need to be able to run code on that data that streams in. In Alooma, we call that component the code engine, but you can call it many different names. And then the next part, and that's something that usually is not, it's not well thought out in many ad hoc data pipelines that we've seen, is the schema repository. Or how do we do schema detection, schema translation, automatic schema amendment of the target? So how do we deal with schemas? And I think that actually I'm delving into a rant here, but there was this concept of schema on read. And that concept was actually pretty strong for a long time. It was like, okay, let's have a data lake. Let's spin up an Hadoop cluster. Let's shove everything in there and then take care of the schema when we read the data. And I think that conception has a lot of flaws, because then you are unaware of schema changes until you're actually trying to read them. And then you found out that you have a data swamp and you don't know where anything in the data lake even resides anymore. So that schema on read concept actually, let's say for maybe 4 or 5 years was ruled the data integration world. And I think that today more and more companies are moving off of schema on read and are moving into schema on write. But at Alooma, we try to put it as one of the core components of the pipeline. Understand what is going through the pipeline, understand the schema, understand how the schema evolves, and create a schema repository with all the history of the schema changes. And then, of course, apply it whenever it needs to be applied. And then the last bit that is also often overlooked is how to handle errors. What happens if something doesn't fit the schema? What happens if something doesn't fit the bill? If a component is down, if your Redshift cluster is not responding, if your processing logic is flawed, how do you gracefully recover from those without getting that page in 2 a.m? So these are the main components that we've tried to build into the Alooma architecture. And this is what we had in mind when trying to design a data pipeline as a service.
And touching a bit more on the topic of schema on read versus schema on write is that when you're just shoving the data into the data lake without processing, without even looking to see whether it fits the intended shape, it will easily hide a lot of potential errors in your source data or your processing logic until it's too late, until you've already tainted or malformed the data beyond any sense of recovery. So to your point of having some sort of error catching, when you do that schema on read, there's no point at which that's even possible until there's no way to recover from it, and you potentially have terabytes or petabytes of data that is completely useless.
Yeah, exactly. I completely agree. And I've been using data lakes myself as well, and have seen that happen. I've seen it go wrong, go right. So I definitely don't recommend that approach today. Yeah, I agree.
And one thing, too, as far as being able to do the processing with the code engine or in the ETL workflow, one thing that seems to be gaining a lot of prevalence is the concept of ELT, where you do the transformation after you've loaded the data in order to be able to maintain the integrity of the original, of the data at its origin versus doing the transformation and potentially either stripping away data or incorrectly merging it. So I don't know if you have any thoughts on that.
Yeah. I might have some thoughts. The approach that we took in Alooma, and I believe in personally, is a two-pronged approach. First, you need to maintain the raw data always. And Alooma, by the way, does that. So we allow you to push your raw data into a cloud storage of your choosing, and it's your cloud storage. So first of all, you have to maintain the raw data for, as long as you want to make sure you can reply it, you can redo the processing logic. So the raw data should be kept raw, of course. But on the other hand, not all transformations are a good fit for a data warehouse. So let's say you are pushing the data into Snowflake, for example, as one of the most fastest growing cloud data warehouse. And you want to do ELT. Not every transformation is a good fit to run on the cloud, on the data warehouse itself. Some are much more efficient to run in Python on the stream itself. So what we do, in addition to storing all of the raw data to make sure that you can always reprocess data and you don't strip out any important information, etc. By the way, there is one exception to that I'll mention soon. You want to support both so let's say ETLT, both transformation on the stream itself and transformations on the warehouse itself. And just let me give you one very funny example from one of our customers. So one of our gaming customers released a version to their game, and there was a field that was usually Boolean, and one developer decided it might be a good idea to fill it with yes and no instead of true and false. Now, if you try to do that as an pure ELT process, you will need to create a new column that is a string or varchar, and then create some SQL to cast that string of yes and no into that Boolean column that you really want to query on. Of course, you don't want to query strings. And of course, you cannot fix the problem at the source, because once you've released an update to something a user runs on their device, they might never update again. You might be stuck with that bad data forever. So there are some transformations that make so much more sense to run on the stream that I think a pure ELT approach is often destined to fail. On the other hand, of course, you cannot do everything. ETL is not a solution for everything as well, because some transformation you do make much more sense to run as SQL. So the approach we took is an ETLT approach, where you can run code for transformation that transform the data on the stream itself, for things that are more efficient to do that way, and then we provide a mechanism to run scheduled queries on the data warehouse side. So you can schedule a job that creates roll-up tables, creates facts table, denormalize schema, things that make much more sense to run in SQL. So I think you need to try and get the best of all worlds there.
And going back to the architectural level of what you've built at Alooma, there are these different components and different aspects to it, but I'm wondering if there are any particular pieces that you found to be the most challenging to be able to scale as you grow the business.
That's a great question. I'm almost tempted to say every piece, but even maybe let's dive in a little bit more. So one piece that's actually surprising at first is if you want to get clicks to events, you need an endpoint, and you need that endpoint to be on the internet. You needed to be able to accept data from all clients, millions and millions or hundreds of millions of different clients, and they could be browsers, they could be mobile devices. They just send you the data at all times. And just, creating an event endpoint that is reliable and, you cannot, if that endpoint is not responding, you're losing data. You're losing your customers' data. So just creating that and making it scalable so, it can handle peaks and, things like, Memorial Day weekend shopping spree or the holidays, or sometimes you can have a 10x or maybe 100x picks. Creating it elastic and the ability to just withstand the volume of incoming data, that in itself was quite a challenge. Then let's say you did and the data got in. The first component we have is Kafka. Now Kafka itself is actually one of the most amazing pieces of software I've seen in terms of scalability. It is extremely easy to scale Kafka. And it's very, very reliable. But Kafka is using Zookeeper. And Zookeeper, if you ever get a chance to work with it, it's not one of the easiest pieces of software to scale. The reason that Zookeeper cannot scale for writes. And actually, this is already ancient history, but at some point, Kafka, I think version 8.1 or something, released an update where they don't save the topic information on Zookeeper anymore, but use Kafka for that. And only use Zookeeper for what it was designed to do, which is data collection. And then that relieved a lot of the pressure on Zookeeper. But before that happened, we had tons of issues with scaling Zookeeper, actually, to be able to support our Kafka deployment. On the event processing side, one of the biggest hurdles we had to tackle is exactly once processing. And of course, if you read a little bit about exactly once, there isn't really exactly once. The best you can have is idempotent, which means you might need to repeat the processing on the same data, but you need to make sure that the results stay the same, even if the same data is being ingested more than once. And that the implementation there is not the easiest, because basically what you need to do is you need to move to micro batches, because you cannot hack any single event. That would just be too time consuming. And then when the micro batch fail, you need to be able to reprocess that micro batch without affecting the result. And there is a lot of implementation details of how to implement that, where on one hand you actually maintain idempotency, on the other hand you can withstand scale, because when you scale up you might need the batch size to amend itself automatically. You might need different batch sizes for different customers. You need to make sure that you don't have starvation, because of course every tenant is independent. That was quite a challenge for us as well. We were using Apache Storm for the stream processing component itself. We're actually now in the process of moving off of Apache Storm into Kafka Streams. We are running it in dev for already some months now, and feel like it's ready to move on to production. The reason is that Kafka Stream have become more evolved and implements a lot of the exactly one semantics implementation that we've implemented ourselves in Storm. I think these are the main ones that come to mind.
And in your documentation, you mentioned that you have 5 nines of uptime and in terms of data processing reliability. So I'm wondering how you manage the underlying infrastructure to be able to support that SLA.
Yeah, that's a good question. Actually, it's also not easy to maintain. So I would say our general approach to infrastructure management has two core principles. One is monitoring. And we actually trust monitoring more than testing. Very strict monitoring to make sure that whenever something goes wrong, we know immediately. And the other part is very frequent releases to production. So it's almost counterintuitive when you're saying, okay, how can you maintain 5.9? What happens if you create a bug and you deploy it to production to all of your customers? So the idea is that if you have strong monitoring and very frequent releases and very strong rollback mechanism, if you create a problem, you can recover from it extremely quickly. Then, in terms of the underlying infrastructure itself, we run the processing itself on Kubernetes. So if any component fails, it recovers, and so a lot of redundancy there. And again, as I mentioned, the micro-batch approach makes sure that if some batch failed in the middle, we can reprocess that batch without creating duplication in the data and without creating any missing data. But I would say maybe I should have started the answer with, there is no silver bullet here. There is no silver bullet that tells you, implement this and you'll have 5 nines. It's just a lot of many lead bullets that you need to use and do correctly. But if I had to distill it, it's monitoring and quick deployment. So that, again, any issue can be distilled to what exactly caused it very, very quickly.
Yeah, and I work in the systems management and cloud automation space, so the release often mantra is definitely something that I'm very close to. And to dig a bit more into that, the reason that it makes it easier to manage your systems when you release frequently is that every change set is very small, so it's easy to see what was the difference that caused this error, and it makes it easier then to roll forward rather than roll back, because rollback is largely a fantasy, because particularly if you have anything involving a schema change, you can't just roll back the code and then have everything work again.
Yeah, for sure. Roll forward is what we do most of the times. And then also, if you're doing frequent release, you feel confident to roll forward because it's, again, very small change set.
And so, as you mentioned from the start, you've been multi-tenant in your entire infrastructure, and I'm curious what additional complexities that introduces, particularly when you're processing data from separate customers that may have certain compliance requirements.
Yeah, that's a challenge. Actually, the challenge has 2 phases. One is the technology challenge, but the other is just the trust challenge, because you have to gain their trust. They're telling you, we are going to send our crown jewels, our most important data to you, to the cloud, and for some companies this is an abomination. They're not used to that at all. So you need to overcome the trust issues, and that's mostly. You do that with a good salesmanship and external audit. So we have SOC 2 Type 2 and all of those external audits and compliance that we do in order to gain the trust. The other side is the technology challenge, because you need to make sure you don't mix your customers' data. You need to make sure you don't, it's not even mixing data, you don't starve the processing for one customer on expense of the other, that all of a sudden has a surge in the streaming data. And I would say the most challenging part is the code engine, because we let our customers run arbitrary code on our machines. So we have to make sure that it's sandboxed and they cannot get out of that sandbox. Even, let's say we have a malicious customer that tries to get out of the sandbox and read other customers' data. We need to put very strong walls around that to make sure that, and our approach there was, so we separate customer data by using different Kafka topics. That actually also helps us with the starvation, because then we can decide how many partitions we have per customer and how many processing units we have per customer, and we can deploy those separately and even scale those up and down separately. So we start by having different customers on different topics. That's one. The other piece is build a very strong sandbox around the code engine. This was something that we've worked very hard on. And actually, if you think about it, in every company where you deploy something like Kafka plus Spark, for example, you already give every developer that has access to Spark access to all the data, because they can run arbitrary code and it is not sandboxed at all. Where in Alooma, because it's multi-tenant from the get-go, we've worked very hard to create sandboxes around the code engine. Our current implementation of the sandbox, we had several implementations throughout the course of life of Alooma. The first one was based on Jython, and the Java Security Manager was used as a sandbox. Eventually, we've moved off of that to Docker-type sandbox with extra hardening on the host itself. So the customer code will run inside their own Docker, but then outside of that Docker, the host itself is also hardened. So especially on the networking front, to make sure that that code cannot escape from that container that it runs in. And then on the audit and engineering side, we have no engineer in Alooma has access to any customer data. in order to be able to access it. Let's say we need to do something for support or something for, to help a customer monitoring alert pops. They will access a service inside Alooma that provides them a temporary token, and then they can access the customer's system or data with that token. And then, of course, it's audited, everything, and that token expires after some time. So so by default, we restrict the access to no access.
And in the code engine, you mentioned that it uses Python and your initial implementation used Jython. I'm wondering what your reasoning was for using that as your language target and whether you have plans for expanding the supported runtimes.
Yeah, sure. So originally, the use of Python was because those were a lot of the requirements that we've heard from data engineers is we want to use Python. It was a language of choice at the time. The original use of Jython was because of that's how we implemented the first sandbox. We definitely plan to support more runtimes. Now that we run it on top of a Docker and it's not tied to any runtime engine that's language specific like Jython, it's much easier to add support for more languages. We now have Python 2.7, Python 3, and we will add at some point in the near future JavaScript, Ruby, and Scala. And again, now it's very easy for us because we have an API, and any Docker that can speak that API, we don't care what it runs under the hood, essentially. The system does not care.
And one of the things that you mentioned early as well is the fact that you have this schema repository with schema versioning. And I know that one of the options that you support is automatic schema management at the destination based on the schema that you introspect. So I'm wondering, what are some of the potential pitfalls of doing that automatic management of the schema in the target?
Yeah, that's a great question. It actually depends a lot also on the type of data warehouse you want to write the data into. Because the main pitfalls of automatic schema management are with data that is semi-structured. Actually, that actually brings to the point I want to mention earlier. So there are two main pitfalls. One pitfall is that there is some data that you don't want to write to data warehouse. So if you do automatic schema management completely, you might write data that you don't want to reach the other side. It's mostly around PII data, so personally identifiable information. Sometimes you don't want that even to hit your target data warehouse. So if you have automatic schema mapping and you add a PII field, it's being written automatically. And actually, it's also relevant to the raw data as well that's being written to S3, for example, or to the cloud storage. Because this is one exception to raw data, especially now with the GDPR looming on us, which is a new regulation for the EU, data privacy and protection. Companies, they don't want to store PII data because it's they need to get from every EU citizen, even if they reside outside of the EU, they need to get extensive permission and they need to be able to delete it, etc. So sometimes they don't even want to store it in the raw data. So this is one aspect if you do automatic schema management and every new field is automatically being written, you might write data that you find secret or you don't want to write for reasons of compliance. The other aspect of automatic schema management really depends on where you write the data into. Because for a data warehouse that supports semi-structured data, like for example, variant data type in Snowflake, there isn't a real risk. Because everything that's nested will just go into that semi-structured data type and the risk is very small. If you write your data to something that don't support it, something like Redshift where Alooma will automatically flatten everything, and then you start sending a bunch of keys in that JSON data that comes from your app or from your game or whatever, and it just adds more and more and more columns to a target. At some point, you're going to get a very wide table, and that can be a problem, both with performance and the storage space. So that's another pitfall. And also, string length is a common pitfall. Let's say you want to compress the data into a string. Alooma found out that the data usually fits into 5 kilobytes of string length, and then all of a sudden you have one event that it has longer string in it. So all of those are pitfalls that might happen to you with automatic schema management. However, I'm not sure if you can avoid them if you're doing it manually. So yeah, you can avoid not writing secret data, but let's say you map things manually. It's also very difficult to know upfront what's going to be the string length of a specific data point from now to the entire future. Now, if the data, by the way, is coming from a source with a strong schema, let's say it's coming from an Oracle database, or it's coming from Salesforce where the source data has schema attached to it, I don't think there is really a risk because, you're guaranteed that the data will conform with the source schema. But if it's a free schema or semi-structured data, then you might run into risk of creating too many columns or too short of marker columns.
And in the case when you elect not to have the schema managed automatically and you do have source data that no longer fits the specified shape, will that just automatically end up in the restream queue to be processed manually?
Yeah, exactly. So Alooma has 3 modes actually. So the first mode is auto-mapped, which is what you mentioned. The other 2 are strict and flexible. So strict means if you have a new field or you have anything that doesn't conform the schema, put it in the restream queue or in the error handling queue. And flexible means stream it anyway and just alert me. Just let me know that I have new field I need to map, but it's okay if you stream the data without those fields for now until I take care of it. Now, of course, you don't risk losing any data because the raw data is still being stored, so you can always reply it. But the question is, do I want to wait and have the data in the restream queue, or do I want the data to stream anyway and then take care of those extra fields at my leisure?
And the risk of having data that changes shape without any sort of warning is increased by the fact that you support source data that is outside of your control, particularly from these various SaaS applications. And given the large number of integrations that you support, I'm wondering how you maintain the code base to be able to interact with these various APIs and various source systems, particularly as new versions are released and schemas change or API specifications change.
Yeah, this is a large part of it is a hamster in a wheel job. So we have a team that's responsible for tracking those API changes, and for every API we support, getting all the release notes, understanding what needs to change, and make sure we are in front of the API changes always. Actually, one thing that caught us off guard was the Facebook API changes after the Senate hearing. They did like a bunch of sudden changes without any warning, so we had to run faster inside the wheel to make sure we are on top of that. But generally speaking, it's a lot of work. Just hundreds of different APIs, making sure you're on top of all of those. We do have like a generic infrastructure that makes it much easier on us, like something that we only need to basically put in the API URLs and the paging mechanism and the authentication mechanism, etc., and then it creates all of the code to ingest data automatically. So there is a lot of infrastructure around it as well. But it's also, eventually, if an API changes version, you have to make sure that you know of it, that the new version doesn't break anything, etc.
And when somebody is first getting started with onboarding onto Alooma, I'm wondering what the workflow looks like for setting up the various integrations, what initial preparation is necessary, and how much of that is managed automatically by Alooma.
Yeah, it should be very simple. So let's say you log into Alooma, what you would see is you would be able to put credentials for your data warehouse and then add integrations just by clicking a button in the UI. So you can add, let's say you're adding a Google Analytics data source. So you add a Google Analytics data source, you give Alooma authorization to OAuth, you choose the report that you want to ingest, and that's it. Alooma has the automatic schema detection. Generally what we call it is a one-click mode. So once you click finish, there is nothing else to be done on your side. Just wait and see your data coming in, being ingested, schemas are created, tables are created. The entire processes in order to ingest the data are being created automatically, and the data makes its way to the target. That's the normal flow. Usually there is not much preparation except of credentials, of passwords. Some data sources require more preparation. Let's say you want to ingest data from a SQL server using a change data capture. You need to enable that on your database. Sometimes that requires your DBA or the admin that manages the SQL server to enable that up front. But for most data sources, especially for the SaaS ones, it's a matter of putting in the credentials and just sit back and enjoy.
And when you refer to watching the data come in your case, that's actually fairly literal, because I know that one of the features that you provide is that live view of the data flow as it's coming from the various systems, so that you can have a visual representation of how things are moving and be able to potentially identify issues just by doing visual pattern matching of either, this looks normal or this looks abnormal, this data source isn't processing appropriately, etc.
Yeah, definitely. So the live view actually started purely as an eye candy. It started as many of the Alooma employees are data engineers themselves and used to be data engineers for many years. And for them, one of the things that came up from the Alooma employees was that the data engineer always has the CEO only knows about them when something breaks. If everything works, no one even knows they exist. It's like a very gray and sad place to be, where people only know about your existence when there are problems. So one of our front-end engineers wanted to create an experience where they would be able to showcase their work even when everything is working. So, hey, look at this cool visualization. It's our data. It's flowing. You can actually see it, see the dots moving. And this was pretty cool as an eye candy. But even after we rolled it out and people got excited about, the eye candy properties of that, we found out there is a real use case to use it. Like, you can filter on things on that screen and then see the data flows. Like, you see, okay, event is coming from the web, then it goes into the MySQL database, then something updated in Salesforce, and I see it coming from Salesforce. So it's really useful for gut check, for making sure the data flows correctly, exactly like you said. But the story behind it is it started purely as an eye candy.
That's funny. And speaking of use cases, you have a fairly extensive set of potential use cases described on your website, but I'm wondering if there are any situations where it actually doesn't make sense to use Alooma, where it's more useful to build something in-house, or if there's a particular scale of company where they're more likely to have the in-house expertise to be able to build something that suits their needs better than something that Alooma can provide.
Yeah, sure. And the main thing, and that's actually our first qualifying question to every company that we speak to is, do you want to move to the cloud? Because if a company is set, and we've met, especially bigger ones, we still want to use our Hadoop on-premise data lake, and we want to ingest data from our data sources into that data lake, Alooma is not a good fit. We are focused around moving data to the cloud. It doesn't make any sense for us to take the data out of your data center to the cloud only to push it back into your data center. So this is one place where I think Alooma is very useful for anything that involves a cloud. Either you are boarding the cloud and your data is already there, or you want to migrate into the cloud. Companies that want to stay on-prem, then Alooma will not be a good fit. I would say in terms of use cases, sometimes Alooma is not a one-stop shop. Sometimes you will still run some software side by side with Alooma. For example, we have one customer, pretty big, that's running a recommendation engine on the data from the website. That recommendation engine doesn't necessarily have to live inside the Alooma code engine. Sometimes it's better to run model training, for example, as an EMR job on the data in S3. So that's okay. I mean, we are not offended. We sometimes even recommend that. We will still ingest the data, we'll put it there, we'll put it in S3, and then you can train your models there using code that's running on EMR. From a vision perspective, of course, I want in 5 years from now, 2 years from now, I want Alooma to be the runtime environment for any data application and support any workload. But the focus today is mostly streaming data and going into the cloud.
And we've spoken a bit about some of the various challenges at different layers of the technical stack for building and maintaining Alooma, but I'm wondering if there are any other big challenges that you either have faced or are facing, whether from the technical or business perspective.
Yeah, sure. I mean, building a company is challenging, especially, that's the first company for me that I'm a founder in, and that's true for all of the founders. And we are lucky enough to have Sequoia and Lightspeed on our investor team, and they're extremely experienced. They've seen tons of companies, and they help a lot in building the company. But building a company is a huge challenge, and we have a great executive team that helps in that. But it's a challenge every day. Even getting the first customers, and then getting from those first customers to the material ARR. Scaling, today Alooma has 130 customers running in production. And again, that's even if I don't know any one of them personally, for example. Let's say in the first 20 customers at the CTO, I knew all of the problems personally. Now there is a team of support engineers that does that. So it's scaling a company we can talk another full session about the challenges there.
And you mentioned that your goal for Alooma in the future is to be this one-stop shop for all data flows, but I'm wondering if you have any specific plans for the future of Alooma or anything in the near to medium term.
It's not a revolution, so it's to evolve Alooma towards that goal. So again, we try to support more extensive use cases. We try to support different types of workloads and more integrations, more languages, a more robust schema repository and error handling, better. It's always getting one step ahead, supporting more and more use cases. In terms of currently we are very focused on growth. In the short to medium term, we are focused on growth. We are trying to grow the company. The goal for us, so I said we are now 130. Our goal is to get to 300 customers by the end of this year. It definitely seems doable with the pace that we've been growing so far. So that's the plans for the medium near future. But again, when I say one-stop shop, I mean maybe it's good to talk a few more minutes about it. If you think about different abstraction layers, the first abstraction that happened in recently was the hardware layer. And I remember, 15 years ago, our biggest problem with every project was that we did not have enough room in the server room to put the server. We didn't have enough power. We had to think, I found myself going over specs of PSUs to see if this is 400 watts or 600 watts, if I can even plug it into the wall. And today we just spin up machines on Amazon. We don't even think about the PSU. We think about the memory that we need, the compute, etc. So that abstraction layer had finished. And then the next abstraction layer with companies like Docker and Heroku was abstracting the application server. So now, of course, we don't install Linux anymore. We just put our stuff in a container and we ship that container into the cloud. But whenever we go to data, we go back in time. We start thinking, do I need a Cassandra, MongoDB, and what type of workload do I have, and what type of database will satisfy that need, and then I need to deploy and maintain all this. The data layer is not abstracted at all. My goal is to be able to create more and more APIs inside the Alooma runtime environment to interact with data, to be able to just say, I need a key value store. I don't care what's under the hood. It could be Redis, it could be Aerospike, it could be whatever. I need a key value store. I need response time of sub-millisecond, and I need to be able to store 1 billion keys. And then you have an API that satisfies that. Very similar to how today we have an API that spins up a machine in Amazon. Hope that makes sense. So that's the vision play, I'd say.
And as a final question, as somebody who is working very closely with tooling and various platforms for managing data, I'm wondering what you see as being the biggest gap in the available tools or technology for data management today.
Yeah, that's a great question. I'm not sure if there is a single gap, but for every specific task that I can think of, there is some tool that created. I think the biggest gap is something that ties them all, ties everything. Because again, today, if you want to take those data tools to build things in-house, you would need to take A and B and C and D and stitch them all together. So I feel like the biggest gap is something that can provide, a tool that can provide the solution for all of those use cases. Not that you will need to use a specific solution or a specific product for each use case.
And so with that, I'll have you add your preferred contact information to the show notes for anybody who does want to follow up or follow the work that you're doing. Well, thank you very much for taking the time to join me today and discuss the work that you're doing with Alooma. It's definitely a very interesting platform, and I am excited to see where you take it in the future. So thank you for that, and I hope you enjoy the rest of your day.
Thank you very much for hosting me.